Okay, hello guys, and we have a new topic now, which is another kind of a force system, no? So wherein we will be working on the resultant of parallel force system. Okay, how to get the magnitude of your resultant? So it is simply an algebraic sum of the magnitude of forces, and for sign convention, if your force is acting downward, no, then the force is taken as negative because upward forces are usually treated as positive. And if it is moving to the right, then positive na siya. Then downward are those forces that are negative, and to the left is also negative. For the location of your resultant, then have to use your Varignon's theorem or the moment principle. Okay? So, compute and locate the resultant of a given system. So, here is your forces acting over the body. Okay, so what is the magnitude of your resultant? It is simply an algebraic sum of forces acting vertically on the body. So, downward, as agreed kanina, is a force that is negative. So, I have negative 12, I have negative 35, and the upward force is 16. So, their sum is equal to negative 31 Newton. Negative 31, the negative indicates downward direction of force. So, that means that is 31 Newton acting downward. That is the net effect of the forces that is acting into the body. Location of R. Okay? So, I can just start with assumption, no? Say, my R is acting here. So, I put my R in between segment BC. But actually, there is nothing wrong if you put your resultant in between A and B. So, since I have to start with assumption, so I take it as my initial location. So, if that is based from a point B, then this distance is dB. And if I'm going to base the distance from A, so this is my dA. And if you're interested with C, you can also call this as DC. Okay? Now, say my reference is point B, so I'll be using B as my moment center. Okay, this one. Now, according to the Varignon's theorem, now, what does the Varignon's theorem say? The Varignon's theorem, so, state that the moment created by the resultant is also the same moment that is produced by the sum of its component, or the sum of the moments produced by the components of your arrow. No? Okay, now, considering B as my moment center, if this is my point B, this one, no? If my B is there, okay, so panalita, this is my B. And my R is here. So, if your R is applied, then there is a rotation made into the body. On that case, that is clockwise. Okay, so if I'm going to treat clockwise moment being plus, so I have 31 times a distance to B. What is the distance to B? I put it as dB. Okay? So this is now your moment equation. This is the resultant of 31. Okay, so 31 times the dB. Positive because the rotation produced by your R, so using B as the moment center is clockwise. Now, for the component of forces, of your force, R, so we have 12, 35, and 16. However, your 16 is located at B exactly, thus, this force will not produce a moment or its moment is equal to 0. Okay? Now, going back to your B as the moment center, if I'm going to consider my 35 is located here, then the force is applied, so it has the same rotation as your arm. No? So, to the body, it produces a clockwise rotation. That is why 35 has the same, 35 times 3 has the same sign with this one. No? Because both, the resultant kanina, nag-produce man o kung sa clockwise rotation. But if you have to go with 12, no, 12 is somewhere here. No? So if 12 is here, then the rotation would be different. No? So don't consider whether the force is downward or upward, but consider the effect of the force into the body. So the rotation is counterclockwise. That is why if 35 is able to produce a clockwise rotation, then 12 is producing a counterclockwise rotation. Thus, these two must have an opposite sign, plus and then negative for the other moment produced by 12. Okay? So, solving for the dB, okay, you come up with a value which is 2.613 meters. The positive result indicates that your assumed direction is correct. This is 3. That is 2.63, so it can be found somewhere here. So maybe a little beyond or beyond this location, because that is 2.63. It's almost 3. But it is really in between BC. So that is the significance of the positive result, because whenever your dB will come out to be negative as the result, then since you started with an assumption, the negative is an indication that ang imong R is not at BC location, but it can be found on the opposite side of B, which can be found right here or maybe there. So it can be found at the left of R. That is how you interpret the plus and minus sign result of your dB. So as notation, we have this. The positive result for dB means that the assumed location of R is true. If the result is negative, it means that R is found at the opposite side of the assumed location. So, the possibility can be here if that comes out to be negative. Just to practice now, in the moment equation using another moment center, I tried to use A as my moment center. So, my reference is A. So, my distance that I'm interested is the dA. Now, the moment produced by your R is also the same moment produced by these components with respect to the same moment center A. Okay? Again, my A is here, no? And you see it, no? If my A is here, then my force is here, which is my R. And again, that's clockwise. So, see, clockwise is positive. 31 times dA. The other two forces, I have 35. No? 35 is here, is also clockwise. So, R, the moment produced by R is plus, so plus and A. 35, and what's the distance of 35 to A? All in all, that is 5. That is why it's multiplied with 5. My 16 Newton is acting upward, and it produces a counterclockwise rotation, opposite to the previous. That is why I take it as negative. The distance of your 16 Newton force to A is only 2. So, that is the moment produced by the component or forces, no? Which are the component of your R. So, we did not include 12 because the moment center is at A. So, the moment of which is 0. Calculating your dA, then I have 4.613. Positive result, it means that it is true that ang imuhang that the resultant I meant is at the right of A. As to the value, we have 4.63. So that is 4.63. So that is beyond. Why 4.63? Because from dB, that is 2.613 I mean. If that is 2.613, then you are simply adding 2 to the value ganina. So that is actually consistent with the previous result. Okay? Now, in problem like this, now it would be good if I'll be mentioning the point which will be used as a reference to have a uniformity of answer than you choosing a point of reference. Okay, but just in case it will not mention any point of reference, so you are free to choose any point as your reference point, and it can be used as a moment center. Now, distributed loads. It is composed of parallel forces whose resultant lies on the centroid of your load diagram with magnitude equal to the area of your load diagram. Okay, we have different types of distributed load. One of which is the uniformly distributed load, no, or rectangular load distribution. Okay? Where is the resultant of a rectangular load? Actually, since there is a geometric center for a rectangle, no? So it can be found somewhere here. Actually, the centroid is a point where the total force is concentrated. So if this is the point at which your R is acting, so this is the centroid of your force. What is the magnitude of your R? This is termed as the load intensity, W. And if the unit of force is Newton and the unit of length is meter, then that is Newton per meter as the load intensity. If you multiply the load intensity with the length, then you can eliminate your M and giving a unit of N for your R because R is a force. So for the location, do not forget, that is exactly halfway. If this is the length of the body over which the rectangular load is distributed, then that is half of L at the left end and half of L at the right end. Okay? So, magnitude is the product of the load intensity times the length. Another type of load, distributed load, is triangular in form. Okay? What is the area of a triangle? The area of the triangle is length times width, and half of which is the area because it is a triangle, yeah? Or 1/2 of length times width. Okay? That is the magnitude of your R. Where is the location of your R? When it is a triangle, from zero intensity value, na, ang imuhang location of R is 2/3. So if you divide this into 3 parts, no, 2 parts will be used as a distance from the zero load intensity. So that's 2/3 of L. If that's 2/3 of L, so that means this is 1/3 of L. So you have to take note of this, no? So 2/3 of L from the zero load intensity and from the maximum load intensity W, so that is 1/3 of L. Area of the triangle, do not forget, it is 1/2 of base times the height. Now, if your load distribution is trapezoidal in form, no, say we have a minimum of load intensity W1 and a load intensity of W2, so how to get the area? Actually, you have to take the average of this. Can you recall how to get the area of a trapezoid? Okay, there is a formula, but it would be easier if you have to break this into 2 parts, no? So, I have a rectangle there. Then, what is left is a triangle. If this is W1 here, and then you have to remove your triangle, isolate a rectangle element from a trapezoid, so a triangle left has an altitude of, what is the value? A difference of the load intensity. So, what is left here is W2 minus W1 because the W1 is used as a uniform load intensity for your rectangle. So, it looks like this. Okay, so instead of having a trapezoid, now where I have to get the area of the trapezoid, no, but if I have to consider directly the area of the trapezoid, the difficulty there is that we cannot locate our R exactly as to its location. Now, that is why I try to break them into parts where I have a rectangle and a triangle. So, my rectangle is your area 1. So, this is my R1. And for my triangle, I have my R2. Then, the distances, if this is R, your R is, by the way, the sum of R1 and R2. So, it is acting downward because both forces are in downward manner. No? They are directed in a downward position. Distances, if I'm going to use A as my reference, this is my D1, this is my D, and this is my D2. Then, to look at my R, then I have to use the moment principle or my Varignon's theorem. No? So, the moment produced by your R is obtained by multiplying R with D. The rotation for this forces, no, are actually all on clockwise. So, that means the moment produced by these forces must bear the same sign. If you take moment clockwise as negative, but what is important, if one is negative, if the first term is negative here, then all must be negative. But since ingon mo da clockwise atong himuon nga plus, then all the terms here have positive signs. Okay, R1 with D1, R2 with D2. So what is your R? It's the sum of R1 and R2. And what's your D1? D1 is taken from the rectangle. That is why D1 is half of L. If this is L entirely. How about your dito? Dito. Your dito is from here. Going there. So that is a triangle. That is I have 2/3 of L. Okay? So 2/3 of L, that means this is 1/3 of L. Okay. Then R1 is L, W1. R2 is a triangle, 1/2 base. What's your base? L. Then the height is the difference, W2 minus W1. Okay? So we will be working on specific situation. Determine the magnitude, direction, location of the resultant. Given. Okay, here is the problem. Body is acted by 3 forces. To get the magnitude of your R, then I have to take summation of forces vertical. Upward forces, positive. Downward forces, negative. 15 and 25 are all downward forces. That is why I have 15 and 25 bearing negative signs. 12 takes a positive sign being upward. So the sum is equal to. The result is negative, and again, the negative indicates downward. So if that's negative 28 kilonewton, and I know that my assumption for negative forces, no, or forces going downward is negative, so that means 28 kilonewton is a downward resultant. Okay? Then I can have the location. Okay? There is no mention of a point of reference, so again, pwede ra ka magpili. No, you can choose any point as your reference. In this case, what if I'm using B? So, I have to plot my R approximately. Then, I put my R right left of B. But actually, since we have to start with assumption, you can put your R at the right side if you like. So, I tried putting my R left of B. So, this is my distance dB. Okay. Now, in Varignon's theorem, okay, I simply indicate na lang that a counterclockwise moment produced by a force will bear a negative sign, and clockwise moment is positive. Okay? Again, let's have again a figure. If my B is here and my R is there, because it is at the left, so what is the rotation it makes? That is counterclockwise. So that is why, if counterclockwise is negative, then I have a negative, that's the magnitude of your R, multiplied with the distance. My B is here again. That is negative because my R is here. Now, it is producing a what rotation? Counterclockwise. And that is why there is a negative because the moment produced is negative. For the component, if this is B, then this force will not be included because the moment of this is 0. Now, how about the other two forces? They are the components of your R. So, 15, negative. Why? Because 15 and 28 takes the same rotation, which is negative. Moment is actually a rotation. Right? But how about kini? This is different because if my B is here, then the rotation can be clockwise. That is why it's positive because ningon man ta, clockwise must be plus. Okay? Sum, divide. So, there, it arrives with a value 45/14, but in a negative result or in decimal, that is approximately negative 3.214. What is the significance of this result? Negative. It means that our assumption is somewhat erroneous. As to location, we assume it to be at the left. So, actually, naa siya at the right of B. So, the location must be here. If this is 3, and that is 3 points, so it is a little beyond halfway. Now, it's the exact location of your R with B as your reference. So, the distance here is 3.214. So, naa ang imong R at the right. That is how you interpret the result. Since B is negative, or that is less than 0, it means that our assumed location is wrong. Thus, R is 3.214 at right of B. Another solution for the location of R using other reference point. I'm using C as my reference point. I started with assumption, ganina, that it is placed in segment EB, downward. Okay? What is the moment produced when I take my C as my moment center? Direct. So, this is not included anymore. So, this is my R creating rotation. So, if this is my point, my R is acting here. So, what does it mean? Counter. So, it is a negative moment produced. Right? So, negative 28 times the distance of DC. Now, other forces like 15. 15 is at the left acting downward. So, it is counterclockwise. That's why this will bear negative sign. How about kine? This is plus because because if I have, where is 12? 12 is this one, no? So, first is this one. 15 ganina. Yes, this one. I am using C as my moment center. So, 15 times 10. Correct? Now, I have 12 dire. And the force is acting here. Diba? Upward. So, that is clockwise. That is why we have 12 times 6. Okay? So, are you able to follow? Minus 28, that is using C as moment center, that is counter. Okay, DC as the distance. Then, this one, the same location. No? The same rotation. That is 15 negative, and the distance would be pila? 10. 12 is here. So, the rotation is opposite, and that is clockwise. No? That is why we have positive. Okay? So, DC comes out as positive. 39 over 14 or 2.786 positive. That means that the resultant is really found where? At the left of C. Well, it is true it is found left of C. But as to the value of 2.786, this is 6, no? So that would mean that the location of your R can only be at this location. Okay? Actually, it is in agreement with our previous answer. Now, because the pilamento, there is a value, something 3 point something. So, we have 2. Yeah, that's the difference of 6. Eh? Okay, so that is how to get the location. Okay? The DB, okay, DC I mean. Since DC, not DB, is positive, and it means that the assumed location is correct. Okay? Put correction, this is DC. That is DC. DC. Okay? So, R is at where? Left of C. Okay? Within BC, but not found in AB. Because as to the value, so we have this 2.786, that is less than 6. Yeah? So that is why we can conclude it is within where? It is within BC and not found in EB as assumed. Another problem. Okay, the load is concentrated load together with uniformly distributed load and a trapezoidal load. Okay, so we can reduce our load, especially the uniform, the distributed loads, no, in terms of a single force. No, we take their individual resultant. This is acting upward, and this is a rectangular load. What is the resultant? What's the product of 10 and 3? That's why I have 30. If that is 3, tag 1.5, 1.5 location. Correct? Okay. If this is 5, okay, I bring my 5 to the left. Okay, so this is 5 times 6. That is also 30. At a location of 3 and 3, right? Okay, that's 3 and 3. Because that is exactly halfway. Now, since I have a triangle here, my base is 6. And if this is 5, which is part of 25, now as I extended it to the left now, so what is left here is only the difference. 25 minus 5. So I have 20. So that's the load intensity of your triangle. And this is for my rectangle. I already have the resultant of 30. What is the area for this triangle? That's 1/2 base. Then, height is 20. That is why I obtained 60 Newton for this resultant. Being a triangle, so that triangle, that resultant will be acting at the centroid. And previously, there is a figure shown that each location from the end will be 1/3. So what is 1/3 of 6? This is 2. 2 na diha. Okay? And that is pila 4. Okay? Now, what would be the magnitude of your resultant? Okay, summation of forces acting vertically. 50, which means this force, downward. Then 60, downward, negative. I also have 30, negative. But I also have an opposing force going upward, 30. That's why there's plus. These two are out, being plus and minus. Okay, by additive inverse identity, that's out. So your resultant is taken from the sum of the two, which is, okay, also negative. It means 110 Newton is acting downward. But where is the location? Okay, I simply go with assumption. And I take A as my moment center. Okay, usa lang ka point, eh? Using A as my moment center. So this is the distance dA. So that is the distance of your resultant from A. I assume that my R can be found where? Right of A. By the way, your R, no? It might be that you can encounter result like this, that your R may be located outside the body. That's possible. No? It may be dire. No? So, do not be confused if your distances that may come out would be an indication that the resultant can be outside the body, because there are really instances wherein the result can be like that. Okay? So, let's have the location by using the moment summation. And again, this is my figure. By using the moment principle, I take my A as my moment center. Okay? So, the resultant will produce again. Okay, itong balikan. My A is there. And my R is there. So, it will produce clockwise. So, this time, positive ilang product. Okay, so we have 110 times the dA. This is your R. And I can go with the component. So, if my A is the moment center, then only this forces will produce moment. Okay, 60. Where is 60? This one. 60 times the distance to A. If that is 60, this is already 3. That is 1/3 of 6. So if that's 1/3 of 6 from here, is the location of the resultant, that would mean this is 2. And if that is 2, 2 is only from B. So 2 will be added to 3. That is why I obtain 5. 30, where is 30? This one. Clockwise happen. So 30 plus. Clockwise, eh? Okay, plus. The distance of 30 to B is halfway of the base, which is 6. So, this is 3. But my reference is A. That is why I make it 6. No? Now, last is a force going upward that we're able to produce an opposite direction, which is counterclockwise. That is why I have a negative. It is exactly halfway of 3. So, that is why the value is only 1.5. My dA comes out to be a positive 87 over 22. The result is positive. It means my value is correct in my figure, no? Okay. So, there is somewhat wrong in the editing, no? dA is positive or dA is greater than 0. It means that the assumed location is correct. 3 point, that is 4, no? So, if that is 3, so, this is somewhat very close to the accurate position. No? So, it is true that is at the right of A because it is plus, and that is our assumption. No? Okay, so thus your R having a magnitude of 110 acting downward is 3.955 right of A. Okay, so that's all in relation to system of forces or system of parallel forces. Okay, so thank you for following, and I hope I was able to eliminate your confusion. Okay, so thank you and goodbye.